Okay, good morning. Happy Friday. And let me get set up here. First things first, you saw last night I moved homework 3 due date to Monday. I'd been contacted by several people that were really lost on how to do this, and so I was giving advice, and my feeling is if I got contacted by several people, there was probably a statistically significant number of people who are having trouble that could use the extra time. And as you saw, I also provided some advice and template files to use if you choose to use them. You don't have to. There are multiple correct ways to approach the problem. So homework 3 and P2 are both due on Monday. What I want to start talking about is P3, which is got 2 parts to it. One is the software design. So the first part, right? Remember, you're coming up with, in P2, you're coming up with a description of what you want your software to do. And in P3, you're showing your design that you think can achieve that. So that's one part. We will not talk about that today. We'll talk about the design next week. And then the other part of P3 is putting down some formal requirement specifications and test cases. That's what I want to talk about today. So if we look at the formats for these things, I'm asking you to give me 3 things. The UML class diagram, which we're going to talk about next week. And you take your diagram and you put it inside your software design document. You put it inside the document that you're delivering for P2 and resubmit that. It has to be inside there. I will not grade it if it is not inside there. The way you do that, I use PowerPoint, and that's how I usually make my class diagrams. And then once I build it in PowerPoint, I save it as a JPEG. I take the JPEG and I insert it as an image. There are online tools. I'm not particularly fond of them for this course. Some students like to use them. Draw.io. Draw.io saves things in a proprietary format that I cannot read. So if you're going to use something like that, I would take a screenshot, make it a JPEG, and put the image in your software design document. Well, then I need 5 requirements and I need test cases, 15 test cases. So 5 requirements are going to be 2 points each, 15 test cases, that's one point each. That's what we're going to talk about today. So I have from SC300 a set of notes. I'm going to adapt them to this class, and I'll publish these notes. That will probably be next week. And so this document, these notes have a lot more information than we need for the class. I'll put a summary section up front that has the critical information for this class. But let's talk about, so pardon me while I fly through these because I need to get to the ones that pertain to the class. This requirement specification. Technically, there's a distinction between requirements and requirement specifications. I basically ignore that distinction in this class. When I talk about requirements, I'm really talking about the specification. The specification is a very formal, very stylized way to write down the requirements, the expected behavior for specific pieces of functionality of your software. And I'm only asking for 5 because I just want you to get the feel of what it's like to create a requirement specification. When you go to SC300, you'll do more. If you're in the EECS department, when you go to Capstone, you're going to do a lot more. So we'll talk about what these things are, how they should look, and then talk about how to document them. So I'll talk just a little bit about the software requirement specification. I do give you a template. Okay, You want to specify the correct behavior. That's why you do it. You have to specify the correct behavior. The customer says, hey, I'm going to give you, $2 million to deliver this software. They kind of want to know that it worked. They want to know that they actually paid for something that they wanted and will operate in the way that they expected. You can't do that through just informal language, handshaking. The way we all test our software is, hey, let's try a couple inputs and see what happens. You have to do it through a rigorous requirement specification and test program. And it is difficult. So one of the things that that students start to struggle with here is the degree of specificity, the degree of granularity that you have to deal with. It may harken back, if you remember, when you very first time you ever programmed something, and this is one of the things I enjoy when I encounter students. It's the first time they've done programming ever, and they start programming, and after a few minutes or a half an hour, they realize, man, I have to tell this stupid computer everything. It doesn't know anything. And you push down the degree of granularity in your thinking, right? When you're doing this step-by-step operations to make something happen. And you may have experienced that when you first encountered programming. The same thing is going to happen here. And until you get practice thinking in those terms, it is not obvious and not easy to put together a good requirement. Once you here's the bad news. Once you get used to thinking in those terms, it turns out requirements are still difficult. They are difficult to do. But the first step is to think in terms of how specific you can be. Again, think in mathematical terms. In your math class, if they give you a formula and they say solve for X, there's basically, there's one correct answer. If they give you Y equals some function of X, and then, here's a value for Y, there is one specific answer. And everybody has to get the same answer. That's the level that we're looking at. Key word on this slide is in boldface, shall. You have to use the word shall. You shall use the word shall. That has become the legally universally accepted terminology for the software has to perform this way or it failed the requirement. And if it fails the requirement, you don't get your money. The examples below gives you a format. The system, class, method, system, software, whatever. The system shall have some capability within some performance parameter after some initial condition or event occurs. So the system shall send a message within 5 seconds after send is pressed. There you go. By the way, that's a bad requirement because we didn't say what the message is. This slide is a good one because it tells you what kinds of things to avoid. Best, most. I don't know what best and most are unless it is rigorously defined. And even then, most people won't use best or most. They'll use terms like maximal or minimal because they've defined mathematically how to calculate those things. User-friendly, easy to use, cost-effective, those kinds of things are not generally good for a real requirement spec. We'll talk about how we have non-functional requirements and sometimes they show up there. Vague pronouns, always be specific about what you're referring to. Ambiguous, almost always, usually. What the heck is usually? Is it 50.1% of the time or is it 99% of the time? What's almost always? 51% of the time? So You have to avoid terms like that. You literally specify what the rates are. Open-ended and non-verifiable term as a minimum, provide support, right? These things, they're not testable. You can't, you can test them, but everybody gets to argue about whether you passed or failed the test. Loopholes, if possible. The system shall do this if possible. I've already met that requirement. I just say, it's not possible. It's not possible because I refuse to program it. Therefore, it is not possible and I've met your requirement. And negative statements. The system shall not. You don't put those things in. You cannot prove negative statements. We basically put requirements into two types, functional and non-functional. We're only focused on functional in this class. The non-functional ones tend to be the ones that are harder to verify because they have to do with things other than specific behaviors of the software. So we want to stick with functional, the things that state explicitly, here's what the software does. If you provide the software with this input or this initial condition and ask it to perform an action, this is the specific action that gets performed. Now, we're going to use natural language, which is inherently ambiguous. So there are some issues with requirements. They are hard to write. Even when you are doing them and you have a fair amount of experience with them, it is difficult to create a good set of requirements. Now, as you know, in your homework 1, homework 2, I put in requirements, not so much because they were needed for the homework, but to give you examples of how to write them. And as you know, on homework 3, there's a set of requirements that Dean Lager wrote, and they are there, again, specifically to get you used to thinking about software development in these terms. How do you write a requirement? How do you specify the behavior of the software? And then how can you test against it? So use those as models. There are two ways that students tend to lose points on their requirements. One is they don't use the model. They don't say the system shall, the software shall, the foo method shall. They don't use just the format. And then the other is they make them too general or non-testable. The system shall operate correctly. I don't know what the heck that means. So the point is we're using natural language, inherently ambiguous. We want to use the system shall type modeling like you see in the previous slide and you see on homework 1, 2, and 3 examples, and then be very specific. You know, what was the hair? The hair height is between 400 and 1,000 meters. Is that ambiguous? It actually is, because we don't know if it's inclusive or not. But notice how specific it was. The hair shall begin at a height of 400 to 1,000 meters. That's testable. If it starts at 399, I failed the test. The non-functional requirements we don't need to go through here because, again, we're not going to focus on them in this class. A lot of them have to do with things like you see on the second bullet, the regulatory practices, maintenance issues, software complexity, software code size. These are not things that relate directly to the function of the software. I'm going to fly through a couple of slides here. Let's talk about the documentation and look at some examples. What a surprise, there's a standard. We're engineers. All engineers in engineering practices have standards, and so there's standards for software requirement specifications. And if you look at the standard for software requirement specification, here's a good summary of a table of contents for one. It has a bunch of parts to it. And what I've done is I've abstracted away the stuff that doesn't make sense, in my opinion, for this class to require of you to do, because you haven't had the experience yet or the other background material yet. So in P3, I'm not asking you to put in this many sections in your document. I give you a template. And the template is here. Change fall 2020 to spring 2021. And it has just 4 sections. The introduction. Every document needs an introduction. You always have to tell the reader, what is this document doing? Why did I write it? Why do you want to read it? Right? You always have to tell that. This document is going to provide the test and requirement specification for the blah, blah, blah project, whatever you named it. And then you probably should remind people what that project is. And then background information. In background information, I'm asking you to put in every definition you need for your requirements to make sense. Do not put definitions in the requirements. And you just saw the requirements need to be very specific, as specific and non-ambiguous as we can make them. How can we do that? We define terms. So define the terms ahead of time. And I think if you saw in homework 1, I defined in homework 2, which was the surface area of the box, edge length of the box one. And I defined for you what those formulas were, so that when I did the requirements, I had a very clear, unambiguous pass-fail criteria. So everything you need to define for the requirements to make sense has to go here. Now, I expect, an 8 to 12 hour process to write this document, not because it's so long. It's only going to be, when you first turn it in, it's going to be, other than the title page, 3 pages long or so. But it's because there's a lot of thinking that has to go on here, a lot of planning, a lot of, what does it mean? What do I need this term to mean so I can put it in the requirement? And then the requirements themselves, I'm only asking for 5. And then the test cases, which I'm asking for 15, 3 for each requirement. So in a real world situation, right now I'm asking for 12 user stories in this class. You probably would have 30, 50, 80 user stories. I'm asking for 5 requirements. You probably would have 60, 80, 200. I'm asking for 15 test cases. You probably would have hundreds. I want you to get the experience of doing these things without overwhelming you with having to do an actual, honest to gosh, complete set of user stories, requirements, specifications, and test cases. I give you a format for the test cases, the requirement ID. Oh, okay, you should have your user stories identified, number them. Then your requirements. Well, why do you have a particular requirement? It's there to meet a user story. The user stories drive the requirements. So now you can say, oh, I've got user story 1 and then requirement 1.1. What does that mean? Well, that's the first requirement from user story 1. And then I can have requirement 1.2, which is the second requirement from user story 1. And then maybe your test case ID would be 1.1.1, 1.1.2, 1.1.3. What does that mean? That's the first, second, and third test for the first requirement that came from the first user story. That kind of thing. You may just decide to number your requirements 1, 2, 3, 4, 5. That's fine too. I would recommend your test cases should be 1.1, 1.2, 1.3. So you know what the test cases are testing, what requirement they're related to. It doesn't hurt though if you also tie your requirements to your user stories, and we'll talk about that in a little bit too. Why do you even have this requirement? You should never do anything if it's not required. Why do you have this requirement? Oh, because of this user story. And then as usual, references, appendices, these kinds of boilerplate portions of the document. You may have some overlap between the discussion that you put in the P2 project description and your background information here. That's okay. If you had formulas in P2 and you need to use those formulas in your requirements and test, you duplicate them here. You almost certainly should have your software design document as a reference here. Because where did these requirements come from again? They came from the user stories. Where are the user stories? They're in the software design document. Where am I? There we go. Questions so far? We'll get into examples in a minute. I like this slide. The requirement specification carves the universe of systems into two sets, those that meet the customer's needs and those that don't. That's kind of an important distinction because those that don't are the ones you don't get paid for. Don't worry about this one too much. There's only one line in this slide that I really care about. The SRS is not a design document. To the degree that it makes sense, and you need to push for this in your own writing, you talk about what, not how. What will the system do, not how will it do it? Very rarely do you need to put in a how kind of statement. We're going to see some examples later on where they put the how in there. And usually the only reason you want a how is because the customer specifically said, this is how I want you to do it. Other than that, you focus on what. You don't want to constrain yourself. You may find a great way to do something that nobody else had thought of or your customer didn't think of. And you don't want to be limited by the fact that there's a requirement that says you have to do it a particular different way that might not be a great way. Also, remember the whole point of these exercises. You want to get a good, strong understanding of what you are trying to do. And then when you enter the design phase, then you start thinking about how you want to do it. Now, since I'm asking you for your UML diagram, which is effectively it's a diagram of your design, you are doing design work for in the P3 period, which means you can, if it makes sense, leverage them in your requirements. But as a general rule, your requirements should be more about the what, not the how. Usually the requirements come before the design. They lead the design. I need to skip some more slides. Okay, principal characters. Now here's where we can start looking at examples. And again, the degree to which you need to think in granular terms and in testable terms is generally new to students. And as you know, until you actually do anything, you're not that good at it usually. And so look at examples. Things that seem perfectly reasonable, requirements that seem perfectly reasonable to a person who is new to this are actually horrible requirements. So let's look at some examples of how and why. And so the examples on the bottom of the page, SRS1, in the event of a power outage, the system shall support basic operations while being powered by a backup battery. And there's all kinds of things wrong with that. We don't know what basic operations are. That's not been defined. And we also don't know for how long. So here's the question you want to ask yourself. Ask yourself this of all your requirements. How can I cheat it? If I wanted to be a cheat, how would I cheat it? Well, here's the first way I would cheat this. In my opinion, there are no basic operations. There are no critical basic operations. Therefore, I have already met the requirement without doing anything. And then if you get past that, I can say, okay, we've all defined what basic operations are. I'm going to power them for half a second. Good luck. So that's why in the bottom, they put both of those things in. In the event of a power outage, the system shall support operations A, B, and C for 30 seconds. Oh, okay, so you're specifying exactly what operations have to be maintained and for exactly for how long. And that actually might be for a minimum of 30 seconds, not because the way it reads, it kind of reads exactly 30 seconds. You might want to put in for, for a minimum of 30 seconds while being powered by a backup battery. And I would actually quibble with that, a backup battery. Why would I quibble with backup battery? Because that's a how. What we need is an alternate power source. So why should I require that it's a battery? What if some places, as soon as you lose power, they have generators that kick on effectively instantaneously. And so the backup generators may do it. Or some people use instead of a true battery, chemical processes, they use a capacitor bank, and the capacitor bank supplies power for 30 seconds or 2 minutes or something like that. So I could get rid of backup battery and just say alternate power source. I might even say alternate non-interruptible power source. We also need to know what a power outage is. Technically that might need to be defined. Is a power outage if you have a power dip, and people will get into the details of this, it will be important in a real world system. If your power, which is currently at say, 120 volts, 60 cycle, if it dips below 80 volts for 1/10 of a second, is that a power outage or not? I have situations where our lights flicker in the house. Is that a power outage or not? So those kinds of things would need to be defined in a real world situation. And believe me, in an avionics system, they worry about that a lot. Most avionics, airplane power systems are weird DC systems, or 28 plus or minus, 32 plus or minus 4 volts. And they worry about, what if it drops below 28 volts? Okay, usually you can allow that for 10 milliseconds or something like that, right? These things really get down into the weeds. And so start thinking about, what do these terms really mean? How can I cheat them? How can I make sure that everybody agrees on the same terminology? It's not easy. And even after you get experience writing requirement specifications, it is not easy. That's why you software engineers are going to take at least one more class just on this. And if you take a master's class, you're going to take a master's course in addition just on this. Okay, they need to be consistent. So here's the examples on the bottom again. Just go to the bottom of the page. System shall provide a response to request A within 5 minutes. And then the system shall provide a response to request A in 5 minutes. Okay, first of all, what's the response, right? The response is not defined, so that's not great. But the question here is, are those two things in conflict with each other? It turns out if you start to do a bunch of requirements, you can have two that are in direct contradiction of each other. The only way to meet one is to fail the other. So in your case, you're only going to do 5. You're not going to run into that problem, but it's an issue that can come up. In 5 minutes, within 5 minutes, in 5 minutes could be interpreted as exactly 5 minutes, which, by the way, you should never do. 5 minutes plus or minus 1 second, right? Something like that. Traceability, we don't need to worry about this for this class, but I do want to mention it. The idea of traceability is that you have a link from the user needs to a requirement, to a user story, to a requirement specification, to a test case, to a test result. If you're writing software, you kind of should ask yourself, why am I writing this software? Oh, I'm writing this software because I have to meet this requirement. If there's no requirement to do the thing that you're writing, don't write it. Again, I'm assuming that we have a complete requirement specification. You've only got 5 for your for your project. So there's going to be things that you're writing that you do not have a specific requirement for. But as a general rule, you're working out in industry, you are earning money, but you are costing somebody money. And the idea is, why are you spending your time doing something when there's no requirement for it? So that's what traceability is about. Oh, and it works both ways. From the customer standpoint, they say, here's what we want you to do. Prove to me that you did it. Oh, okay, we can do that. Here's what you wanted us to do. We created these user stories. We created these requirement specifications. We created these test cases. And look, we passed all our tests. And from the developer standpoint, it goes the other way. Why am I writing this code and why am I testing it? Oh, I'm testing it because I had to meet this requirement. Why did I have to meet this requirement? Because I had to do that in order to fulfill a user story. Why is the user story even there? Oh, because the customer had these needs. So that's what traceability is about. And it is a big deal in industrial applications. Okay, verifiable. Now let's talk about this. So the system must be user-friendly. This is the other place where students tend not to do well with requirements, is they have things that are not verifiable. They're not testable. You really want your requirements to have two qualities, atomic and testable. Atomic meaning only one thing at a time, and testable meaning that you can actually run a test with a clear pass-fail criteria. The system must be user-friendly. What do you think? Clear pass-fail criteria or not? Of course not. In fact, even if someone were to use it and say, this is not user-friendly at all, I would say, that's not my fault. We have a bad user. That user was not competent. But my system is user-friendly. This thing's not competent. User interface shall be menu-driven. It shall provide dialog boxes, screens, radio buttons, da, 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 da. What do you think? Verifiable?
It may not be specific enough.
It may not be specific enough. Yeah, that one's a tough one. That one's a tough one. I struggle with that one. And here's one thing. What if it was partly menu-driven and partly not menu-driven? Did that still meet the requirement? Because it doesn't say entirely menu-driven. So I think that needs to have a little more stuff. Now, what you would do with that one, by the way, and this is fairly common, people will write these broad requirements, and then how do they test it? They actually underneath it write very specific requirements that are testable. So sometimes that happens. The system shall usually generate an output within 10 seconds. Can we verify that one? Is it testable?
Yes, that's testable.
Yes? How would you test it? Well, let me ask you this. What is usually?
Ooh, I missed that part.
Ah, yeah, usually. That's the problem, right? So usually might mean 50.1. Oh, but it might also mean, right, 99.9. People actually have defined these things. Shouldn't surprise you, right? In industry, they have reliability levels. You know, is your system operating 99% of the time, or 99.9, or 99.99? And these are accepted standards. So instead of usual, you actually have to put in a percentage. And then how do you test it? Well, you have to test it by just testing it a statistically significant number of times. So now you've got to bring in your statistician and say, I need to know, you know, I need to get a good statistically significant test. The specification would have to be done in such a way that you are saying that you are, you know, within 10 seconds, this percentage of the time with a 3 sigma error, something like that. The system shall generate output B within 10 seconds of event A occurring. What do you think of that one? I notice that you're skeptical. That's good. That's good. Be a little paranoid. Be critical. Can you cheat that system? Can you cheat that requirement?
I think it's verifiable. I can't think of a way to really cheat it.
Right?
I think you
Right.
could cheat what event A, like, I think you could cheat like the definition of the events and the outputs.
Yeah. And that's the key to this one. Assuming that event B is a clear, effectively 0 time length event, and event A is a clear 0 time length event, this is probably good. However, we can construct situations where this would not be good. Let's say event A takes 20 seconds, right? Some things do. Event A takes 20 seconds. So does output B have to occur when event A begins or when event A ends? So sometimes you worry about timing issues. You guys that are online gamers probably worry about lag. That's the lag problem right there. And you can get, worse things. What if output B actually takes a long time? So, what if you're generating your output? What if the system crashes and it's generating a log file and the log file takes 20 or 30 or 40 seconds to produce? I used to, back in the day, I would, run software and then I'd go down and get my output, and my output was printed out and it was, 200 pages of output or 300 pages of output. That didn't happen in 10 seconds. So should output B be initiated within 10 seconds of A, or does it need to be completed? Those kinds of things, as long as now again, if A and B are effectively zero time events, we don't get into those situations, but you can consider situations where this would be a problem. Event A is when the light comes on in the nuclear power plant that says, I've given you an indication that event A has started, and event A is, core meltdown, and it takes a minute. So then does B happen to be, within 10 seconds of the beginning of A or 10 seconds at the end of A? Because that makes a big difference to the community. So again, as long as these terms are well defined and you're in a good, clear space, that's a good one. But we can construct situations where it's not verifiable because it's too ambiguous. It's very common to have these problems. The system shall respond to users' requests quickly. Yes, dear, it's no. I know. Yes, dear. My wife says no. No, of course not. And we don't know all users' requests. We don't know what, the main thing is we don't know what quickly means. And of course you want to specify the request. So as you go further down, we're getting better. The second one is where a lot of people will stop. The system shall respond to users' request A within 2 seconds. But as a programmer, here's the response I'm going to program. Do nothing. I keep hitting this button and nothing happens. Yeah, that's how I designed it. I met the requirement by doing nothing within 2 seconds. So now it's, oh, okay, you have to respond to user request A with result B within 2 seconds. And we're back to the same problem as before. As long as A and B are effectively non-time events, right? 0 time events, then we're in good shape. See how you have to drill down to the details, how you have to think in a criminally minded way. How can I cheat this? You should look at other people's requirements and say, how can I cheat this person? It's a good mindset to be in. Engineers, we act ethically, but in order to act ethically, you have to think of all the off conditions that can occur. And it takes time to do that. I took a class on cybersecurity many years ago, and the professor kept giving all these examples. Here's a system, is it secure? And I'm like, looks secure to me. And then he's like, here's 47 ways how it can be hacked. You have to learn to think in a devious way. System shall be completely reliable, modular. These are not very good measurable things, right? Completely reliable. We don't know what reliable is. Oh, errors in the system shall be less than 99%. That sounds good at first because it's got a number in it. But if you think about it, a system is usually composed of multiple subsystems. So does that mean every subsystem has to be at 99% or the whole system as a whole? Because I might have one really bad subsystem that just keeps crapping out on me, but the whole system overall is 99%. You can come up with other ways to cheat these things. And I'm not going to worry too much about the systems response time for all level 1 actions, as long as we know what level 1 actions are, you know, that kind of thing. Don't worry about cyclomatic complexity. That's an analytic measure of your software. 95% of the system's transactions shall be processed in less than 1 second. Here's the good news and bad news. You'd think 95% is a good number, but the way statistics works, you actually have to say 95% of the system shall be processed in less than 1 second, 90% of the time. See what I'm saying? So, because let's say I did a test of 100, you know, I just ping this thing with 100 transactions, and I do 100 and I pass the test, and I do 100 and I pass the test, and I do that 49 times. And on the 50th one, I fail because I only got 94% of the systems. Well, wait a minute, is that system actually meeting the requirement or not? If you aggregate all the tests, yes, it did. If I only take that one little test set, it didn't for that one time. So that's why in statistics, they don't just talk about 95%, they talk about 95%, 95% of the time. I don't know if there's any AEs in here, but you guys take materials classes and they talk about strength of materials. This steel can withstand 100,000 kPa. Oh, but if you look at the fine print, 95% of the steel that you get will withstand that 95% of the time. So these kinds of things that look great actually get drilled down. I would recommend in your requirements, stay away from statistics. That's why I get sometimes requirements where people want to do random numbers, and they'll say this will be a random, the random distribution will be a bell curve, or the random distribution will be even. And I'm like, good luck proving that. My recommendation is not to put that in. Okay, let's look at some examples. There we go. These are from previous semesters. The player shall move left using the move left function. I don't mind too much that the move left method, not function, method, the move left method was mentioned, because again, you've got some design in your UML diagram at this point. You've already determined classes, attributes, and methods. If you want to put this method shall, rather than the software shall, this method shall, then that's okay. Oh, door slam. All right. So the player shall move. That's a tough one. That's a tough one. I think it's really, this is who's actually performing the action here. The action is actually the move left function. It really should be, if we're going to name it, the move left function shall move the player character or the player whatever, you know, the player object, not the human player. You know, I press the keyboard and I hit the left arrow key and I don't jump to the left. My character on the screen does, which actually means we have a character object with an X and Y location, and we've modified the X and Y location. That's what it really means. Forget what you see on the screen. Down in the guts of it, like with the sheep, we've got X and Y location. And if we move left, if we inject a command to move to the left, it should move that X and Y location. So we have a player shall move left function. I would rewrite that. Okay, the move left function shall move the player object left. How far? See how I can cheat this? 1,000,000 miles. Oh, wait. 1/1,000,000 of an inch. So you specify. shall move the player left 10 units every time it is activated. That kind of thing. And you can see the fourth one down. The torch shall prompt a message to be printed for the player. It apparently doesn't matter what the message is. You see the detail that you need. By the way, we don't know when that happens, right? You need to have a trigger. The torch shall prompt a message to be printed for the player. Oh, okay. Actually, the torch shall print message A when event B occurs. And you might have a bunch of those. What if the torch has 6 different messages? That's 6 different requirements, right? Okay. And now let's look at test cases for a minute. I'm asking you to do test cases, and the key here is you have to be so specific that if you handed your test plan to 10 different people, they would all perform the exact same test. So under the top test case here, requirement 1, test case 1, when player uses the move right method as the initial conditions and input, and then it says expected or output behavior, a program will run the move method and move the player and the player model 15 pixels to the right. There's way too many words in there. Okay, so what we need is more specific values. First of all, how do I know the player moved 15 pixels to the right? And I wouldn't use pixels, that's what's on the screen. I'm gonna push you guys to ignore what's on the screen. There's a player object and it has an X location, Y location in units, 15 units to the right, let's say. So how do we know it moved 15 units to the right? I run the move right method and my player is at X location 78. How do I know that it moved 15 units to the right? I don't, unless I know where he started, he or she, it. So your initial conditions are actually player object is at 0, 0. Move right method called. Expected output, player object is at 15, 0. That's measurable. Now, how do you get those attributes? You write test cases in your software. You remember, you're writing software. You can write anything you want. You can write test cases, and then you can run your code just to run test cases. There's actually, we don't get into it in this class, there's actually, Eclipse has a really nice testing feature called JUnit testing. If you want to use the JUnit testing, by all means, go ahead. We don't have it in the course because you've already got enough to do, right? You guys are pretty busy already. So we don't need to add to complexity to the course. But I have had students use it in the past and become quite pleased with it, because the idea is once you write your test cases in the JUnit, you can automatically just rerun your test cases. Every time you change your code, you automatically rerun all your test cases. So in future classes, you will do that. I just want you to know it's there if you want to experiment with it. So you understand what I want for the initial conditions and the output, really specific. Okay. Now, here's an example of people being specific. So the requirement here, the program shall be capable of taking the derivative at a point the user provides, provided as mathematically legal. I'm assuming you've defined what mathematically legal means up in the background information, but that's a nice, it describes what, it doesn't describe how. And the terms derivative, point, function, these are all well defined. Again, that should still be defined in the background material, but these are well defined, understood terms. And then look at the test case. Input the function x squared and the point x equals 1 and the output is 2. And if I gave that test case to 10 people, they would all do the exact same thing. They would put in x squared and they would put in x equals 1. And then they would get an output of 2. And they would all agree that that software either passed or failed the test. Okay, questions? You're going to have questions as you start to drill down in this for sure. But questions real quick before we go. You're overwhelmed. You're confused. It's all perfectly clear. You think you get it, but you want to try it for a while.
I'm just confused.
Okay. All right. Well, again, look at homeworks 1, 2, and 3, where you have lots and lots of examples of requirements. And for homeworks 1 and 2, you have specific examples of test cases.
Sir, I have a quick question
Yes.
regarding P2 due Monday.
Yes.
So for the second document, do we have to fill all the tables, or it's just like a line or 2 lines on the tables?
The tables, yeah, the agile tracking sheet.
Yeah.
Yeah, so there's a table that says sprint 1, 2, 3, and 4. You only need to fill out for sprint 1. And then you're going to do 2, 3, and 4 as you enter those sprints. And even there's a column that says completed, user stories completed, right?
Yeah.
So no, you haven't completed any of them. So it's just backlog, what user stories you're attempting in sprint 1. And those are the only 2 boxes on that table you need to fill in.
Okay, and table 1 and table 3, we don't do them?
And table 3, which is the burn down, right? You're
Yeah.
a plan and an actual. Your plan is totally filled out. Just take your total hours of effort that you think you're going to have and linearly drop them down week by week by week till you get a 0 at the end. That you fill out because that becomes your yardstick.
Do we change the dates? Because there's the
Yeah. You have to change the dates.
yeah, because they have the October and November and stuff.
Yeah.
Okay. Perfect. Thank you.
Sure. Okay, we're way over. Some of you guys got to go to other classes. So thanks for being here. Have a good weekend.